Welcome everyone to the video on the JK flip-flop waveforms. In this video we will see that we have a JK flip-flop. It's a negative triggered, or NGT, negative edge triggered flip-flop. So that means that the flip-flop Q's output is going to change on the negative going transition of the clock based on what the J and the K inputs are. Alright, so how do we analyze a circuit like this when we have waveforms applied? Here we have the waveforms applied to the inputs. For example, this is a clear input, this is a set input, here's our clock, our J, K inputs, and here's our Q outputs. These are the waveforms that are applied to those inputs, and we want to determine what the waveform looks like for the Q outputs. Now, the way we do that is we look at the inputs to the various J, K inputs and to the asynchronous set and clear inputs. We can start off by looking at the clear and the set. Notice that set is always high, therefore it does not have any effect on the Q output. However, the clear input is high but then momentarily goes low. Based on previous videos, we know that as soon as that happens, then the Q input is going to go low. So we'll start that, we'll assume it's at low, but then it'll remain low. Okay, so it starts off, the Q output will go to low. That occurs due to this transition there. Okay, now since after that point then clear goes high, then the asynchronous inputs will have no further effect doing this waveform on the Q outputs. And at that point then the clock takes over and the JK inputs have effect on it. Since this is a negative going transition here due to the bubble, then our outputs are going to be activated or take effect on the negative going transitions of our clock, which will be at these points here on each one of the clock inputs. So we can then see that I'm going to draw a dotted line if I can. As straight as I possibly can, representing each one of these conditions. Alright, so we're going to look at the negative going transition of each one of the clock inputs. And we have 6 of them here. Alright, this will be number 5. And then finally, we have number 6. Now that we have specified when the clock takes effect, we can go back now and look at the condition of the J and K inputs and how they would affect the Q output. For example, on the first clock pulse here at 1, at this point here, we notice that J is high, or 1, and so is K. Both of them are 1. So from our knowledge of the transition table of what occurs here when J and K both equal 1, then Q toggles. So that means that Q will come along, and then at this point in time it will go from a 0 to a 1, and then it will remain so here. Okay, and it stays that way until the next clock pulse. We come down and analyze the condition of J and K at the next clock pulse. This would be here. We notice that J is at 0 and K is at 0. So that means that there is no change in the output. Therefore, Q remains constant, in this case at a logic 1, until the next transition, clock transition. That occurs here. Okay? And going down we see that J is equal to 0, but K is equal to a 1. So that means that the flip-flop will be cleared. So it goes from a 1 to a 0. and then remains so until the next transition. Now, at this state here, then we have another clock transition, and we have J equal to 1 and K equal to a 1. What occurs then is when both of those are 1, we toggle. So the output goes from a 0 to a 1 and remains so until the next clock transition. At this clock transition, okay, number 5, we got J equal to 0 and K equal to a 1. Well, based on the transition table, this is a clear condition, so the output Q goes back to 0 and remains there until the next clock transition. At the final clock transition, we have J equal to 0 and K equal to 0, which means that we have this no change. Therefore, the output does not change and remains at 0. That concludes the video on JK flip-flop waveforms.